Welcome, everyone. Thank you for joining us for today's webinar. Today, we're presenting API Sentinel, Continuous API Visibility and Risk Monitoring, presented by Cequence Security. Our presenters today are Dr. Edward G. Amoroso, Chief Executive Officer with TAG Cyber, LLC. Ed has been an adjunct professor of computer science at the Stevens Institute of Technology for the past 27 years. He's also a senior advisor at the Applied Physics Laboratory at Johns Hopkins University. He's the author of 6 books on cybersecurity and dozens of major research and technical papers and articles in peer-reviewed and major publications. Also joining us today is Subbu Iyer. He's the Vice President of Products with Cequence Security. Now I'm going to turn things over to Subbu to begin the presentation. Please go ahead, sir.
Thanks, Don. Hello, everyone. My name is Subbu Iyer, and as Don mentioned, I run product management at Cequence Security. I'm very excited today to announce the availability of a brand new service from Cequence called API Sentinel, which allows enterprises to get continuous visibility and risk monitoring of their APIs. And joining me on this webinar is a distinguished luminary from the industry called Ed Amoroso, an ex-AT&T executive. I'm honored to have him on the call here. So we're going to be talking about APIs a whole lot during this presentation. The product is all about allowing enterprises continuous visibility and monitoring of their API attack surface. So APIs are really transforming the industry as we see it today. Many enterprises that we talk to, no matter what vertical they belong to, they are transforming their businesses for the modern customer experience. Whether that is to their suppliers, their partners, their end consumers, they're really building a modern customer experience all driven around APIs. So as we know, right, we consume services like Twilio and Stripe. The entire business models of such applications are built around APIs. So as enterprises are building APIs that they expose to their downstream suppliers or partners or customers, and are consuming APIs from other vendors, the attack surface is tremendously changing from the old perimeter-based model. So I'd like to call upon Ed for your thoughts on APIs. Ed, to start off with, are enterprises thinking about security differently for APIs? Is this something that enterprises are thinking about these days?
Well, they are. And first of all, thank you, Subbu, for inviting me to participate. I love this area and got very excited when I looked to see what you guys were doing. So, again, thanks so much for including me in the discussion. You and I both know this is a long progression toward focus on APIs. If you go back a number of years, the way people thought about their business was more in terms of physical or tangible things, right? If you and I ask someone about their business 20 years ago, probably tell you about their physical plant, their equipment, their facilities, their people, hardware. That was more tangible. And over time, that just changed. And, certainly in the post-2000, it's been very obvious, right, as we watch companies like Amazon and Salesforce and others become big, powerful entities. But this progression from physical to virtual, with that, what I've noticed, and I know one of the things that you and your team have noticed, is that your applications kind of become your business, Like where before, applications were these things that were just sort of part of a business. It's more just your apps are your business. If you're going to describe, instead of physical plants and buildings and equipment, they say, well, what is your business? Immediately you're describing all these virtual entities that sure look like workloads or applications to you and I. It's software, because software now is the matter on which businesses are built. So it shouldn't surprise anybody that application security became a big area. Now, you and I also know that this topic of software security, application security, has been a tough one. You go back to the early days when we were hoping at the earliest days of software engineering, and maybe it's possible to write perfect code and anticipate all the requirements that would come from users and developers and partners. And we all know it's impossible. You just say that's where the genesis of DevOps, that You basically have to have this dynamic means for building software. And we have to assume, you and I both do security, so it'd be crazy for us not to assume that vulnerabilities are going to be embedded in almost any non-trivial code that's developed. So you start with this premise that applications are your business, and oh, by the way, vulnerabilities are inevitable in software, then you've got a little bit of a problem, right? You got this issue, well, what are we going to do? We should protect ourselves. And there have been all these different initiatives, most of them excellent. Like, I've always admired software process improvement initiatives. That's a good thing, to make the software process better. I've watched, frameworks for maturity and process. Those are good ideas. And we've seen scanning as an important part of the process. When I worked back at Bell Labs, I remember first seeing lint. When you were writing the C code, you'd go through and it would talk little things that ought to be fixed in your code. Always been a good idea to do that. But I think more recently, we recognize the importance of runtime protections. And there's been a lot of different approaches, behavioral, and I think machine learning has been promising. I know at Cequence, you guys are big proponents of using machine learning. I count me in that camp as well. But this led, I would say about 20 years ago, to the genesis of emphasis on uniform interfaces. It was a PhD thesis 20 years ago at UC Irvine. Roy Fielding wrote a thesis that at the time I remember sort of hearing about it. We were all learning what a REST API was, but he kind of invented this idea that you'd have this uniform transactional interface, stateless, that would allow for what ultimately, I guess you could argue, is the way companies like Amazon grew. Like, could Amazon be what it is today if we hadn't had uniform interfaces? Because before it was always this ad hoc interfaces. So that's kind of the progression the community has taken. And for all those reasons, Subbu, I think, people now, today, as APIs really do dominate the way companies integrate their functionality with others and expand and allow for very organic growth of their service. It doesn't surprise me that API security would become a new, essentially new quote-unquote category, and I think you guys do a fine job dealing with that. So I hope that's a good sort of summary of how we got to where we are.
Yeah, that's very helpful. And going back to the old client-server applications model, which gave birth to a whole set of vulnerability scanning products and a whole bunch of security products. What are some of the top-of-the-mind needs for enterprises as they are thinking about this API-first world that we are in right now?
Well, first of all, I don't think we have to convince too many companies that we do live in an API world. You would probably, I think we both have a little chuckle that you go back just a few years. We might even have to preface the discussion by convincing people that as they build out some sort of capability, particularly in e-commerce, online, that sort of thing, that a uniform service interface would even be necessary. So it's good to see that people are there. But you know what I think is sort of top of mind is that we have these threats that keep happening, right? Like it's almost beyond belief that some problems that surfaced originally, like injection attacks, are still happening, right? I mean, the reason they happen is because they work, and because many of the API interfaces that have API designs that have been put in place just flat out didn't have means for dealing with these types of problems. There's a bunch of others, So I think it's a very, Subbu, I think this is very empirical and a very practical, experience-based kind of need. Where API security, I believe, has grown out of need as opposed to like somebody cooking up an idea somewhere and then vendors coming out because they suspect it might be useful. This is one of those rare protection initiatives I've seen in my career, and I've been at this for 40 years, where I think it did grow specifically from the challenges that developers were seeing. And I'm sure in the next 20 minutes or so, we'll go through some more examples. But anybody listening here could probably list off a dozen or so familiar and sometimes not so familiar problems that occur between software in their communications or interfaces, and as a result, API security is a necessity. It's not a should have, it's a must have now. Yeah.
Actually, you mentioned developers, which is a very interesting point as well. APIs are typically associated with modern applications, microservices-based applications, service mesh type applications. And these applications are typically built with modern DevOps procedures in place, which allows developers to get their code out to production faster than ever, really. So really the time between writing code and getting it into production, into the hands of consumers has never been shorter. So is that also affecting the security posture that enterprises are thinking about?
It certainly does. I mean, anytime you reduce cycle time, you introduce the possibility that you might be skipping a step, right? If you and I are a couple of developers and we're, involved in a traditional SDLC, then we might have had the luxury to take the time to do the tedious regression, security testing, and code review, and all kinds of things that might take time, but are completely inappropriate in during a sprint or something where you're trying to push code out. So what has to happen is, A, you need automation, and B, that automation needs to be flexible. So if you don't have those two things, then you're going to hold up the DevOps process. It's not going to work. And again, I think as you'll share in a little bit when we go through some of the capability of your platform, without automation, I don't know. I don't think any of this works. I think you really do need to have those functional hooks that allow you to keep up with what you just described, which is not, and it's not going to slow down. It's going to get faster, right? With the offense doing more and more automation, bot attacks that so much more automated, smarter, that we're going to be forced to just get better, and we're going to be more dependent on automation in the API security area, I think. And that's okay. As long as we have a means, and I think your team has done a nice job here, we'll be all right. And frankly, it probably in the long run we'll get a more robust product if we're dealing with automation as opposed to manual techniques, like in the old days where you do code review and things. So you always miss stuff. That's not a very thorough means for doing it. So yes, the speed does dictate certain capabilities.
So that really brings DevOps to the front of the security process, if you will, of API-based applications. So security almost has to share the responsibilities with DevOps, appropriately building in automation and testing of these APIs, whether they are conforming to the specifications and all that, even before they are brought to market, if you will.
I think that's right. And I know that with your team, you guys will tend to interact with both the application security teams and the development teams. And that's good. Like I'm an example of somebody who's kind of evangelized closing the gap between those groups, because it's dumb for there to be a gap. Security shouldn't be this thing that you just do after you build something. That retrofit approach is a terrible approach. You'd rather have this intimacy between the application security planning and design and the actual DevOps processes. It's funny, we're saying DevOps. People might wonder why we're not saying DevSecOps or SecDevOps. The reason I never say is I never know whether the Sec goes in the front, the middle, or the back of that term. But, you really should be, the security needs to be integrated and embedded right into the development frameworks. Whether you're doing container, cloud, or whatever, whether you're managing or orchestrating, whatever you're doing, the security needs to be embedded and integrated. And that does demand that the teams work together. You sure hope that organizationally, like if there's some managers listening, you want to do everything you can to make sure that your development and security teams are adjacent and cooperative and working toward common goals. But you've probably seen cases, as I have, where those two teams work at odds. In the old days, the security team was like the team that always said no. That can't be the way you do it. it has to be a partnership. And I think you see it more, but, I bet you there's some people listening to us right now who may work in places where there's still some gaps between the dev teams and the security teams. That hopefully will go away at some point.
Yeah. And I think the best way to do that is to actually provide both of these teams the visibility and insights that they need from APIs. That itself will provide a tremendous insight into the risk posture of these APIs, as we'll talk about during the remainder of the webinar. So, and how about I just walk through the capabilities of the new service, and would love to get your ideas as I'm presenting some of these capabilities.
Yep, love it. Let's go through them.
Good. So, as I mentioned, I just talked about these APIs that are being built by enterprises to interact with their businesses and for the new business model. They are increasingly under attack. And why is it so? Because it's really easy to do that. It's really easy for an attacker to find an API definition, whether that is through published open API definitions that an enterprise publishes for their target consumers or their customers, or from their mobile applications. Mobile applications usually tend to consume the backend services via APIs, and it's fairly trivial for an attacker to be able to reverse engineer a mobile application and be able to tell what backend API endpoints it is talking to. And finally, documentation. Documentation tends to exist a lot for APIs, so attackers can usually find out the API definitions to a lot of painstaking detail, what parameters it consumes, and things like that. So this often leads to various attack vectors. For instance, the application business logic is now exposed to the customer. There are potential vulnerabilities lurking in by hidden parameter values being exposed by the developer. Though the API definition might state that they are exposing only a certain set of parameters, often an API is found to expose above and beyond that. And those often lead to privilege escalation attacks because the attacker discovers that by setting certain parameter values, they can actually get their privilege escalated. That's a particular attack that happens. It's common for internal error messages or response payloads to contain sensitive information, almost accidentally in most of the cases. But this often leads to the attacker actually finding interesting internal database IDs or other information that they can then use to stage an actual attack. So that's another attack vector that happens. And in general, lack of visibility and oversight, whether it is about anything anomalous or malicious happening with APIs, or with stolen API keys or API keys that have been breached to get into accounts or to actually carry out operations on the back end that wouldn't otherwise have been allowed. So the ideal security solution for API should really provide a security team with a real-time inventory of all runtime APIs. And this includes all the known APIs that an enterprise has published, as well as these hidden shadow APIs, as we call them, that may be exposed to the enterprise world or to the external world, but the enterprise just doesn't know about. Allow the developers to build secure APIs. So as Ed mentioned earlier, enable the security team to be an enabler of faster business processes and not be an obstacle, not always say no to faster and nimble processes. Allow the developers to have a process where they are eliminating vulnerabilities even before the publication of these APIs. And finally, give the security teams a near real-time risk assessment of their APIs. So we're very excited to announce the availability of a brand new service from Cequence Security called API Sentinel. API Sentinel has 4 key features. One is it allows enterprises to watch and monitor a runtime inventory of all their exposed APIs. This includes both managed APIs, as in the known APIs, as well as shadow APIs that are exposed and are being used by their customers and their partners and their suppliers. They just do not know about it. So think about these as APIs that are in production, that are being used, but these were probably created in a structured approach by certain development teams exposed to the enterprise, to the external world, and the enterprise just doesn't know about it. Detailed API usage analysis, including insights into where this API is being used from, which countries, which orgs, which IP addresses, what headers and parameters are in use, and so on. Schema non-conformance essentially compares the runtime usage with the OpenAPI definition and flags any deviation from the conformance, such as usage of undocumented methods or undocumented error codes or undocumented parameters, which are being exposed by the implementation but were never in the definition. And finally, a continuous risk scoring, which is a quantitative assessment of the API, each API endpoint, based on predefined risk factors. Let's quickly go through them. Discovering and monitoring an API attack surface. So this basically allows an enterprise to look at the entire inventory or catalog of APIs on the left-hand side, as you can see. It essentially lists all the endpoints that are discovered by the product in their deployment or in their enterprise scenario. This includes every individual endpoint, including the method that is publicly exposed. It also includes shadow APIs that are currently being used. And these are all based on actual runtime usage that is being detected. And on the right-hand side, it discovers the usage trends, like which geos, which IP addresses, which organizations is this API being consumed from, and it discovers the headers and parameters that are being used as well, along with a frequency-based assessment of which headers are often being seen in the requests or responses, and which ones are less frequently seen.
Hey, Subbu, this is Ed. I wanted to ask you quickly about shadow APIs. Wondering, as you work with your clients, how often does that come up? It would seem to me, that shadow has always been the scourge of auditors and assessment teams. Do you find that this is an issue that's come up? I'm glad it's in the product here. What is the genesis of this? Some things you've maybe been hearing from clients?
Yeah, that's a very good question, Ed. We hear that a lot amongst enterprises as being a potential concern. And the reasons for that are they have a set of applications that they are knowingly, let's say, digitally transforming and moving to one or more clouds. And there are these processes that are being built around these digital transformation apps. But then they do know that there are many applications and APIs that are being publicly exposed. They just do not know the full list of them and what functionality they are exposing to their customers or partners. These may be legacy applications, or these may be one-off functionalities that may be exposed to the external world. Now they are looking at that going, yeah, I know that's a payment application, that's a B2B, a login application, whatever that may be. They know it's exchanging sensitive information, but they have no idea what parameters or what usage statistics there are. And these can become shadow APIs because these are APIs that may pose a security risk for them that they have just not bargained for, that they have just not gotten their arms around.
That's great, thank you. Because usually that's very well-meaning. It's often non-malicious, but put there, and the organization doesn't realize it. So that's good. I suspect that's going to be a popular feature.
Yeah, and above and beyond that, even when an OpenAPI definition is published with, let's say, a bunch of endpoints that are exposed as per the definition, the developers usually go above and beyond that and expose certain endpoints saying, yeah, I'm going to probably need that for my debugging purposes or my troubleshooting purposes. And they build certain endpoints assuming that they would be consuming them. But sure enough, some mobile application that they have developed consumes those APIs, so an attacker discovers them. And before you know it, that shadow API, that hidden API is starting to get external traffic that the enterprise never targets. Those are also potential genesis points of shadow APIs. All right. So moving on to quantitative risk assessment. So once you have discovered what APIs and endpoints are actually exposed, what APIs constitute your attack surface, the product essentially issues a quantitative security risk posture for each of the endpoints. So this includes an assessment based on certain predefined risk factors, which are all functions of parameters such as is this endpoint enabled with access control? And is it a strong form of access control? Or is it something weak like, let's say, HTTP basic auth? Or maybe an API key, a pre-shared key that is being exchanged between the client and the server? Or going all the way, is it like really strong authentication based on OAuth and OpenID Connect, and a bearer token is being exchanged between the client and the server? So it's really, access control is really a spectrum across which you can assess a quantitative risk score. PCI or PII or other custom sensitive data being exchanged over the API is also another risk contributor. So if we are seeing sensitive information being exchanged over an API and it is easily detected in clear text in a header or in the body, that can contribute significantly to the risk of an API. Is the API communication encrypted using TLS, or is it communicating over HTTP? And finally, does this API conform to the definition? Or are you seeing headers being consumed or query parameters being consumed, response codes being issued back to the client that are all deviated or deviant from the OpenAPI definition? So these can all contribute to the risk posture of an API. So really what the enterprise gets is not only an inventory catalog of all their APIs on the left-hand side, but when they click on each of them, they essentially get a real-time security posture or an assessment based on multiple different dimensions. And this can all be filtered based on a time period. So they can see this in the past 15 minutes, in the past hour, in the past day, in the past 2 weeks. So they can see how their security risk posture is changing over time. So how does this work? So we've talked about functionality giving visibility into enterprises. API Sentinel is built as a really complementary product to API Gateway. And we are increasingly seeing that API Gateway products like Amazon API Gateway or Google Apigee or maybe Ingress controllers like Istio and HA Proxy and Envoy and Nginx are sitting in front of these API-based applications or service meshes. API Sentinel is a Kubernetes application that can integrate with the API gateway or the proxy via a couple of mechanisms, either as a sidecar proxy chaining, or even a log-based ingestion that we support with Amazon API Gateway, which gives us insights into what activity is going on between the API clients and the backend application. And that produces the rich insights and analysis from API Sentinel that an administrator can then consume via the dashboard. It is available on Docker Hub registry for download, so you can just grab it from the Docker Hub registry and get it up and going, integrate with your API gateway. It installs in minutes. Once you have the application, once you have the Helm chart, you can be up and running in no time at all. And within the product, there is out-the-box wizards that allow you to integrate with these API gateways or other products. So really to bring this all home, Cequence API Sentinel is really part of a family of products that comprise bot defense and app firewall as well. Cequence really provides this comprehensive platform called Application Security Platform that allows enterprises to build in comprehensive online protection for their public-facing applications and APIs from sophisticated bots and very targeted application vulnerability attacks in their external posture. So API Sentinel complements those products, bot defense and app firewall, by providing this capability for API-based applications. And really the strength of the platform is that this application security platform relies on machine learning primarily and does not require any client-side instrumentation. Typically, bot defense products or WAF products require JavaScripts or SDKs to be instrumented on the client side so that they can get those telemetry signals and then analyze to see if this is from a human or from a bot. Those kinds of products are ineffective, cumbersome to manage from an application development perspective because they considerably hinder the application development velocity. And more importantly, they do not work for APIs. Because in many of the API-based applications, you do not have a client-side application that you can instrument using JavaScript or SDK. Or often it is infeasible to do so. Instead, the Cequence Application Security Platform does all this using machine learning. Machine learning compensates for the lack of JavaScript or SDK signals. It does not require them. Instead, these are codified into out-of-the-box system rules, and there are over 150 system rules provided out of the product. And over and above and beyond that, the customer can configure their own rules or customize and tune the product based on their specific needs. This also provides inline remediation. So as this traffic is coming into the system, Cequence can immediately take action and take a variety of actions such as blocking the incoming attacks or targeted vulnerability attacks or rate limit them or deceive the attackers. There are very innovative techniques provided by Cequence to thwart these attacks right at the entry point and not allow them to go all the way back to your application.
Hey, Subbu, is the kind of the hope here with the machine learning that there might be some preventive approach here that would stop future 0 days, right? Because this area, as you and I both know, has been characterized primarily by looking at the types of attacks that we've seen in practice. Like that's the nature of OWASP and other things where we have this experience, we catalog the problems, and then we inform developers, here are the things you need to make sure you prevent. It's always bothered me because that seems like the AV protection didn't work for that reason. I'm thinking maybe that machine learning might be a way to get our arms around something that's more predictive. Does that make sense?
Yeah, actually, glad you brought that up because the behavior-based, so the machine learning that we have really analyzes the incoming traffic based on 4 key pillars. What infrastructure or like IP addresses or organizations is this traffic coming from? What tools are generating these requests? What usernames and credentials are being used? So we can easily tell if these credentials are simply being played from the dark web as part of a major data breach, like are these just stolen credentials? Or most importantly, to go back to your question, are we seeing behavioral traits in these requests that are telltale signs of an attack or a sophisticated bot? And this is where an enterprise can actually codify behavior or use one of our out-of-the-box rules to essentially build protection into their system that can future-proof their applications from future attacks. And obviously, it won't be a catch-all solution for every possible attack, but we do see that these sophisticated attacks, these sophisticated bots, tend to exhibit behavior that can be captured via machine learning rules. We do see changes in behavior or mutation in behavior of bots that are all usually predictable using machine learning. So yes, to answer your question, the behavioral-based aspect is a tremendous help in being able to do that.
Good. That's a great feature.
So, and really complementing all that are REST APIs that are provided from the platform, both to consume threat intelligence that we can ingest from a variety of different vendors that we source threat intelligence from, and this includes threat intelligence about bad IP addresses, bad organizations, reputations of those IP addresses, and so on. And we can integrate downwards with other applications as well, including maybe a SIM application and a SOC application, a SOAR application, and so on. So downstream integrations are supported from the platform as well. So that's in a nutshell is essentially what API Sentinel provides. and API Sentinel complements these existing products of bot defense and app firewall and is part of a comprehensive platform called Application Security Platform, which is primarily a machine learning-based platform. So that brings us to the last slide of the presentation. Excited to announce a free trial program for API Sentinel. Go ahead and access our website on the link below. Go to www.cequence.ai/API Security free trial and fill out a simple form, and one of our sales representatives will be in touch with you very shortly and allow you to get your own free trial immediately. Free 30-day trial that you can use to get visibility into your API. So at this point, I'd love to hand this back to Don and see if there are any questions from the audience.
Thank you, Subbu. As Subbu mentioned, we're going to go ahead and take some questions from the audience. Just a reminder to please make sure to type your questions into the question box in the control panel. It looks like we do have a few questions. The first one that came in looks like, where does API security fit within some of the compliance frameworks like NIST or PCI DSS?
Subbu, would it be okay for me to provide comment here? I know you have some opinions, but I'd like to maybe say a couple words about this.
Yeah, please go ahead.
My observation is that there's nowhere near enough emphasis here. It just seems pretty obvious. We talk about AppSec, which is good. But I'd like to see the standards community and the audit community and the compliance community get a little more aggressive here. I think this has become such a fundamental component of how modern businesses operate that it seems like a big miss in my mind that we don't see more framework emphasis. So if some folks who are listening who have some influence in that community, particularly NIST, I hope we move it forward. There's some nice NIST documents in the special pub series that we do reference this area, but I think for the most part, most compliance programs don't feel a great deal of pressure to include, say, visibility and the types of things that Subbu shared that Cequence and similar companies are doing. So my answer would be I don't think there's enough emphasis, and I hope that changes. That makes sense, Subbu. I think you probably get some business as a result of compliance, but I'm going to guess it's more the security and dev teams just wanting to avoid these threats as opposed to dealing with some compliance framework.
Yeah, I agree with your assessment. Any other questions from the audience, Tom?
Yeah, we do have one more question. This person's asking, how does API Sentinel differ from solutions like 42Crunch and Salt Security?
Yeah, very, very good point. So to start off with, this is a comprehensive API security solution that goes above and beyond just visibility, let's say, or just providing conformance assessment. API Sentinel is part of the comprehensive platform called Application Security Platform, which really includes comprehensive bot protection, application firewalling, threat protection, and continuous visibility, all essentially packaged into a single platform. That really is the differentiator of the platform, combined with the considerable reliance on machine learning and inline remediation of these threats to your APIs. So not only can you get continuous visibility, very rich visibility into your managed and shadow APIs, but you can also protect them from sophisticated attacks like bot attacks or application firewalling attacks, and immediately take action on those attacks as they are happening in your environment. That really sets us apart from the vendors that you just named down.
Okay. The next question that we have, this person's asking if you can drill down a little bit more into the deployment scenarios and architectures.
Sure. So that's a very good question. We do get asked about the deployments in various types of scenarios. And actually, I might just bring up that slide so I can bring that up. So API Sentinel is a Kubernetes-based application that can get deployed in really any managed Kubernetes environment. You can install that in EKS, and we will be supporting other managed Kubernetes environments very shortly as well. So customers can install this in their EKS environment, grab the application from the Docker Hub registry and in Amazon Marketplace and get this up and running. And really, the integration with their API gateways can be really from any environment. The API gateways can be on premises, can be in a public cloud environment like AWS or GCP, and that those can all integrate with API Sentinel. So this really provides comprehensive protection for their applications, no matter whether those applications are residing in a public cloud or within their enterprise.
Okay. The next question we have, this person says that they're using Akamai Bot Manager, which claims to secure their APIs, and they're asking why should they change?
So very good question. We do replace several such incumbent deployments with the Cequence Application Security platform. Typical reasons that a customer states for replacing those products with ours is that our product results in a tremendously lower total cost of operation for comprehensive application security protection. So with Cequence, you are no longer required to manage JavaScripts and SDKs and worry about the next new application that is going to come to market, because chances are that if you are like most other enterprises, you're bringing applications to market or updating applications all the time. So you really don't want to be bogged down by the overhead and hassles of managing JavaScripts and SDKs, which are all required for those incumbent solutions. We don't require those. So right off the bat, enterprises report a tremendous savings and an optimization of administrator time in managing the application. And the other side, it results in tremendously better efficacy as well, because now using machine learning, you are able to codify behavior and catch behavior-based attacks that were not caught by the earlier forms of protection that you had. Besides, it also provides, since we are on the topic of APIs, the sort of continuous visibility and protection that API Sentinel provides is nowhere to be found in the incumbent solutions, incumbent bot management solutions that you just named. None of those provides the kind of detailed visibility and insight into APIs.
Okay. And we have time for one more question today. And the next question is, Cequence is focused on bot prevention. Is this an extension of that solution, or is it something more?
Yeah, so this complements the bot protection and application firewalling that are part of the platform. As I mentioned earlier, the platform in itself comprises bot defense, app firewall, and now API Sentinel to protect APIs. It extends and perfectly complements the bot protection capability that the platform is currently capable of. And these products will feed off of each other. There is close integration between these products. So the ability to protect an application or an API against bots will perfectly complement what that means from a visibility and insights perspective.
Okay. Well, thank you, Subbu. I would like our speakers for joining us today. I'd also like to thank Cequence Security for making this webinar possible. Thanks again to you, the audience, for joining us today, and we'll see you next time.